Domain 3B, using questioning and discussion techniques. ExploreLearning Gizmos provide a variety of ways to facilitate classroom discussions and content questioning during a Gizmo lesson. One of these ways is through the teacher's use of pre-scripted discussion questions that can be found in the teacher guide. The teacher may print out the teacher guide and facilitate whole class discussion by strategically pausing throughout the lesson and infusing a discussion question that is appropriate in deepening students' understanding of the content at hand. The teacher may use the divergent or convergent questions listed to invite students to formulate hypotheses or solutions to a problem posed. The gizmo can then be manipulated as a means to provide feedback. This process may lead to students formulating questions, initiating topics, or making unsolicited contributions to class discussions. No matter whole class instruction or one-on-one computer lab instruction, strategic placement of well-designed, purposeful discussion questions during instruction is important. To add an additional layer of questioning to instruction, the student exploration sheet may be used. Within the body of the student exploration sheet are a variety of procedures and questions that relate to Gizmo tasks. The student exploration sheet may be used to pose a series of questions or prompts to challenge students cognitively and promote metacognition. Start by posing mid-level Bloom's taxonomy questions that can be found in the prior knowledge or warm-up section, or even activity A. Select questions in activity A or B that ask students to hypothesize, experiment, analyze, and draw conclusions. Finally, look for connection or challenge questions at the end of the student exploration sheet. Challenge questions may include word problems or synthesis problems. Let's first look at the teacher guide as it applies to Domain 3B, using questioning and discussion techniques. Upon opening the teacher guide, look for the Suggested Lesson Sequence section. In the Suggested Lesson Sequence section of the teacher guide, recommendations for pre, during, and post-Gizmo activities are provided. During instruction, discussion questions should be infused strategically throughout the lesson to check student comprehension. In the Suggested Lesson Sequence section, discussion questions are listed here as number 4. The discussion questions listed may be infused throughout the lesson to assess student learning along the way, or at the end of the lesson as an informal assessment by using an exit card strategy. Let's now look at the student exploration sheet as it relates to Domain 3B, using questioning and discussion techniques. In flipping through the student exploration sheet, the teacher may select questions that are of different levels of Bloom's taxonomy. These questions may be scaffolded throughout the lesson, whereas the teacher may start with questions from the prior knowledge questions section and Gizmo warm-up, and by the end of the lesson, use connection and challenge questions found at the end of the student exploration sheet. Remember, the activities contained within the student exploration sheet are built upon cognitive complexity. As a side note, it's important the questions selected by the teacher align with learning outcomes and are selected and planned prior to the start of the Gizmo lesson. One highly favored teacher resource that works well to foster questioning and discussion techniques is the Youth Science Canada Smarter Science Steps to Inquiry worksheet. This worksheet, coupled with a gizmo, may be used by the teacher to facilitate structured or guided inquiry. Click on the Steps to Inquiry worksheet link in Aqua to be redirected to the Youth Science Canada Smarter Science website. There, you can download a PDF copy of the Steps to Inquiry worksheet that will be explained next. This PDF can be saved or printed for future reference. Let's take a look at this resource. This is the Steps to Inquiry Level 2 worksheet. There are 5 steps to engage students in higher order thinking through the lens of structured or guided inquiry. Here in Step 1, students may first see the gizmo manipulated 1 or 2 times. During this time, they may be asked to make qualitative and quantitative observations. By doing so, they also become attuned to what the gizmo does and how it operates, saving the teacher time by not having to teach how the gizmo functions. After making initial observations, students may be asked what they are wondering. This may include students proposing solutions to what they've observed, describing what happened and how they think it occurred, or may even lead to students developing other questions based upon their observations. The labeled diagram space provided below can be used a variety of ways, including sketching the gizmo and labeling parts or concepts that may apply. Students may even use the space to propose a possible solution to a scientific design or mathematical solution, especially when working with equations and shapes. In Step 2, students may then analytically dissect the gizmo for variables, including independent variables, dependent variables, and controls. This often leads to students building relationships between cause and effect, or structure versus function, and developing intra and interconnections. Students can write their responses in the worksheet or on sticky notes, which then makes it more efficient for sorting in the next step. Notice the subtle questioning used in Steps 2A and 2B, which makes reference to the lightly shaded vocabulary words found in the boxes. Next, in Step 3, students may now classify the variables they came up with in Step 2. Here, the connection between independent variable and dependent variable intensifies as students develop an understanding for how the two variables are related to one another. If necessary, the controlled variable boxes can be divided further as students analyze the gizmo intensely and identify all the items that will not change each time the gizmo is manipulated. Step 4 offers students the opportunity to design a question for exploration by asking them to identify an independent variable to change and potential dependent variables that will result that can be observed or measured. It is possible that each student may come up with a different combination for this answer, especially when using a gizmo as a virtual experiment. In the last step, Step 5, students may formulate a hypothesis based upon their input for Step 4, and provide scientific or mathematical justification in the space provided. In this justification, students may argue why they think they will gain the results they've noted by providing a detailed explanation, possibly even citing real-world application or examples. In addition to discussion questions found in the teacher guide and the different levels of questions found in the student exploration guide, ExploreLearning Gizmos also offer 2 other ways to challenge students cognitively. These include 5 multiple-choice assessment questions included with each of the gizmos in the library, and a rather unique way of involving students in questioning and discussion by using the snapshot camera feature of the gizmo. Directly beneath the gizmo are 5 assessment questions. These assessment questions can be answered by each student. When a student is finished, they may click on the Check Your Answers button. The 5 assessment questions are instantly graded, and a report opens automatically on the computer screen with instant feedback for that student. In the individualized report, students are able to see the original question and answer options in addition to their answer selection. The correct answer selection, which may or may not match what they selected, is also listed. Most powerful, an explanation of the correct answer is provided regardless if the student answered the question correctly or not. Through this method, a student can be actively involved in collecting information from the mini-formative assessment. The teacher is also provided with an assessment results report that shows all of the students enrolled in that class and their answer options. This is available for each gizmo the teacher assigns on their class tab within their ExploreLearning account. The assessment results report provides the teacher with a way to execute line item analysis in an effort to look for overarching trends, identify student misconceptions that still exist, or areas for improvement while progressing forward in instruction. These assessment questions are designed to be given as a mini formative assessment in which the teacher can make informed decisions during instruction. As a tip or trick, if the teacher wishes to modify a question or answer options, they may highlight the question and or answer options provided and use the copy command. After opening a word processor document, the teacher can then use the paste command. Once the question and answer options have been imported onto the Word document, they can be customized for individualized student needs. Another way to engage students in high levels of thinking and metacognition is by using a feature built into Gizmos during questioning and discussion. the snapshot camera feature, or screenshot. Notice the camera buttons identified on this gizmo. The buttons for the snapshot camera and copy screen feature may also look like these here. Using this feature, the teacher may design a question that not only provides an in-depth understanding of how well the students comprehend the content or skill at hand, but also provides an alternate form of assessment and student choice. Students may use the Gizmo Snapshot Camera feature if working one-on-one with a computer to capture supporting data or evidence to answer the question. Framed around real-world application or a scenario, students can be actively involved in collecting information and providing input. They may then pair their evidence with a summative statement or written justification that is mathematically or scientifically based. Other examples for how ExploreLearning gizmos can support questioning and discussion during instruction include pairing best teaching practices and content pedagogy when using a gizmo. In both math and science, students must be able to use higher order thinking skills for critical thinking, problem solving, and analysis. Look for students informally analyzing the gizmo and formulating their own questions through writing and through discussion. Students may be challenged to analyze the gizmo and assess whether the gizmo does or does not represent real-world application. Students may even perform this assessment on their own as they interact with the gizmo. For example, in the force and fan carts gizmo, if the no friction option is selected, the cart will continue at a rate of speed indefinitely because there is no friction acting between the wheels of the cart and the surface. In this case, students may argue that the gizmo does not represent real-world application because of the absence of friction. They may even cite specific examples such as a car or bus coasting on a flat road and the resulting speed decreasing over time or distance due to friction. As a recommendation, be sure to incorporate opportunities for students to have meaningful conversations about the content through think, pair, share, peer interviews, or turn and talk discussion techniques. Such techniques help to ensure each student has the opportunity to share their thoughts or questions and promote equity of voice among all students. You may now click on the orange EL logo in the bottom right corner to return to the main menu, or wait to continue to Domain 3C, Engaging Students in Learning.